Hey guys, my name is Samilcha, and in this tutorial series or in this video I would be explaining you about AWS Step Functions. So this is gonna be a complete beginner tutorial series. If you do not know anything about Step Function, do not worry, watch this video till the end. I'll make sure that you understand every single aspect of Step Functions. So before we start learning, I would like to share a small video on AWS Step Functions. Before we jump into any of the theories and definition, let's watch a small video on AWS Step Function and then come back to the slides. So let me expand the video and I'm gonna start the video right now.
Hi, my name is Andy Katz. I'm here to introduce AWS Step Functions, a service from AWS that makes it easy to coordinate the components of distributed applications and microservices using visual workflows. Microservices are processes that communicate with each other over a network to complete a larger goal. Applications built as a collection of microservices are more resilient and easier to scale. A very simple microservice, even serverless in this case, can be deployed with an AWS Lambda function. And you can do a lot with just one Lambda function. Sometimes, however, your application requires more than one function. There are many combinations and patterns of 2 or 3 functions. For example, you may want a second function to always follow a first and only run if and when the first succeeds. You may want to execute 2 functions in parallel and feed the combined results into a third. Or maybe you would like to choose between 2 functions based on the output of a first function. You could write a lot of code to choreograph the interaction of your microservices, or you could use AWS Step Functions to coordinate your workflows. It's easy to get started with Step Functions. You declaratively define your workflows in the form of a state machine. Step Function visualizes your workflow, including tasks performed in sequence or in parallel, branching logic based on task results or other input, and timers. Step Functions manages each execution, keeping track of each step in a central audit trail, and managing task timeouts, retries, and error messages with built-in try, catch, finally patterns. Some examples of the kinds of repetitive processes that you can reliably automate with Step Functions include active synchronization of 2 Amazon S3 buckets, requesting a human approval by email and waiting till the authorized person responds before continuing with the workflow, image processing of photos, creating a thumbnail, and tagging image features using Amazon recognition in parallel. Step Functions helps increase your productive time spent on business logic instead of plumbing, makes your applications more agile, and provides resilience at scale. Learn more about AWS Step Functions by visiting our console today.
This was a great video. So this was a really great video that showed the true power of Step Functions. As you can see, the advantages are clearly stated in the video. But now I would like to go a little bit into theory, because understanding a theory and a little bit definition really helps you to answer questions in the interview. So yeah, let's go over a little bit of theory. So let's go to the first slide. AWS Step Function is a serverless function orchestrator that makes it easy to sequence AWS Lambda functions and multiple AWS services into business critical application. Through its visual interface, you can create, run series of checkpoints and event-driven workflows that maintains application state. The output of one step acts as an input to the next step. Each step in your application executes in order as defined as your business logic. Orchestrating a series of individual serverless application, managing retries and debugging failures can be challenging. As your distributed application becomes more complex, the complexity of managing them also grows. With its built-in operational control, Step Function manages sequencing, error handling, retry logic, and state, removing a significant operational burden from your team. Some of the benefits of Step Function are build and update apps really very fast and quickly. AWS Step Functions let you build visual workflows that enable fast translation of your business requirements into technical requirements. You can build application in a matter of minutes, and when need to change, you can simply swap or reorganize the components without customizing any of your code. Improve resiliency. AWS Step Functions manages state, checkpoint, and restarts for you to make sure that the application executes in order as expected. Built-in try, catch, retry, rollback capabilities, dealing with errors and exception automatically. All right, let's code. With AWS Step Functions, AWS Step Function manages the logic of your application for you and implement the basic primitives such as branching, parallel execution, and timeout. This removes extra code that may be repeated in your microservice functions. AWS Step Functions or state machines are defined in a JSON using a declarative Amazon state language. If you want to learn more about Amazon state language, here is the link in the description. Check that out. Now, let's go to part 1. So let's see some basic syntax of a step function and then understand a little bit about this Amazon state language, and then we'll be building all of these on the cloud as well. So let's first of all see how the syntax is. So on the right hand side, what you see is a very simple state machine which fires up a Lambda function called hello world. And on the left hand side, what you're trying to see is basically the state, or is the schema that defines the state machine or the step functions, whatever you want to call. So let's understand what all are the components of this part. So I'm gonna zoom a little bit here. So the first part that you could have, and it's optional, is called comment. So this comment represents the comment of your step function, what this step function or the microservice does, right? So it tells you about that. Start at, this is a required field. This basically tells a step function where to start the state machine. So you might have several steps, right? So in this situation, start at will tell you that which state it has to start executing from. So in this case, I'm saying, hey, hello world is a state that I would define it later. Now all the states are defined in this dictionary object called state. So the key is state, and the value would be your the states that you define. So on the top, you just said that you would have a state called hello world. Now we need to define that state. So here what I did is I said hello world, type as task. So type task, that means it tells that you want to run a task. Resource, you can run various resources, but we are right now firing up a Lambda function. So you would provide the ARN of that Lambda, okay? And then we are saying end as true. When you say end as true, that tells the step function that this is the last step and there is no further steps after this. So very simple steps. As I said, we need few basic components. Comment is optional, start as is required. We have a states variable where you start defining your state, and this is basically a very simple state machine or step function. A couple of definitions just in case if you want to look. A state machine must have an object field named states, right? I just told you that that's a required one, right? This is just a definition. Whose field represents the states. A state machine must have a string field named start at. I already told you that. Whose value must be exactly match the one of the names in the state field. The interpreter starts running the machines at the name state. So I just explained you about that. A state machine may have a string field named comment provided by a human readable description of the machine. So it's an optional if you want to provide. A state machine may have a string field named version, just in case if you want to whenever you change your machine. State machines, if you want to keep a track of versions, you can provide a version. It's optional as well. State machine used in the machine. This document describes the version 1.0, and if omitted, the default value of the version is string 1.0. A state machine may have an integer field named timeout seconds. If provided, it provides the maximum number of seconds the machine is allowed to run. So for example, let's say you want to run let's say your Lambda takes like 10 seconds, but the maximum I would allow is 1 minute. So if in case something failed up, the maximum it can go for is 1 minute. So you could define your timeouts stuff. So these are all the optional parameters, just a description about all of those states. States are represented as a field of a top level state object. The state name whose length must be less than or equal to 128 unique characters. So you cannot write a name of a state which is like a massive paragraph, you cannot do that. Is the field name, state name must be unique within the scope of the whole state machine. So the name has to be unique, right? The state describes the task, units of the work, or specify the control. So this is pretty self-explanatory. I don't need to explain this. Transition. Transition links states together, defining the control flow of the state machine after executing a non-terminating state can be interpreted following a transition to the next state. For the state types, for the state types, transitions are unconditional and specified through a state next keyword. So I'll show you about that part. Don't worry about that. The states can have multiple incoming transition from other states as well. So again, in this hello world example, if you remove this end as true, if you want to go to another state, you could say next and you could provide the name of the state. So in that case, you would go to that. But we'll learn all of that. Don't worry about that, okay? So a little bit about the error. I know this is just a theory. As I said, these are the slides. We are actually going to do all of these things on AWS as well. So bear with me for now. Any state can encounter runtime errors. Error can arise because of state machine definition issues. Example, the result path problem discussed immediately above, task failures, an exception thrown by a Lambda function, or because of transition issues such as network partition events. In any of the situation, you definitely want to restart your state. Well, AWS Step Function takes care of it. All you got to do is provide a retry word, and then you say error equals, and then you can provide states.timeout. That means that if it times out, try to restart the state after 3 seconds, maximum time of 2 and the backup rate of 1.5. So you can define all of these things in a step function. As I said, we're just taking a look at all of these things. We'll go a little bit deep into every single thing. Don't worry and don't panic. Errors. You could define also, for example, if all the states fail, that's an error, right? If states.timeout, so if it's a timeout, then also retry. So you could define, what do you want to do? If a state fail, it's an error, right? If basically everything fails, or if it throws a timeout error, you can do that, right? So all sort of things. For example, Lambda can timeout, right? So you can define all of that in this retry block. Now there is also something called a catch block. Well, the catch block is basically whenever your code returns some sort of error messages. So assume you wrote a Lambda function, and if something goes wrong in the Lambda function returns the string java.lang.exception. Just as I said, you can return this, or you can return the word error, right? The string. So what you're saying here is error equals. If the error equals to this string, then you want to do something, right? You want to go to a Lambda or report that to a business, or you want to publish something on an SNS. So you can do all of that logic in the catch block. So the catch blocks takes care of that. So right here on this example on the right hand side right here, it shows you the retry and the catch block together. So type as task, we are firing up a Lambda, the next state is Y. If something goes wrong, retry that for 2 times maximum after waiting for 1 second, right? And then if all the states fail, then go to a state called Z. So it's pretty easy. You just have to define the JSON Amazon state language, as I said, and the states would do the job, right? It's pretty easy. Now once this is done, now we'll go into demos and examples. So let's go over to AWS Management Console and actually try certain things out and understand. All right, let's get some hands dirty and get actually some practical demo about step functions on Amazon Web Services. So head over to the Amazon console, and then what we gotta do is basically we gotta head over to the step functions right here. Once you're on the console, let's click on create step functions, write your own stuff, and right here shows a very basic step function. So what we will do is basically copy this and click on next. First of all, we are learning, right? So learn one, learn test, right? Let's create a new role, that's fine, and then click on create state machine. This would create a state machine, start, you can start the state machine, and here you can see the input was this. Oops, sorry. The input was this. That was the output hello. Then the input to the second step was hello. The output was world, right? So very simple thing. You can read all the messages here, the logs for each particular step. So you could do all that debugging. Now let's learn a little bit more, right? So I did copy the state machine here. So I'm gonna come here and say hello. Oops, sorry. So now let's grab the state machine and start developing things from this. So here, okay. So let's click on step function again, state machine. So now let's understand what we're doing here. As I said in the slides too, remember we have a comment that describes the comment for the step function that, or the logic that you're doing. Start at hello. If you're saying that, hey, I would like to start the step function at hello, that's the step. And then once this step is done, the result of this step would be hello. I'm just mimicking it. We'll fire up some Lambda now. The next step would be world, and that's the end of the stuff. So, and this is how the step looks like, right? I showed you that. Now what I want to do is, instead of doing this, I would actually want to fire up some Lambda. So let's click on Lambda 1 here. The type would be task because we want to fire up a Lambda. I do have the schema here that I would show you in a second. Resource. Let's first of all complete all the naming convention. Lambda 2. The next would be Lambda 2. Resource would be the ARN for that Lambda. So I have some Lambdas created here already. So this Lambda returns a JSON called message hello from Lambda 1, right? Head over and copy the ARN. So that's the ARN, right? Let's go to Lambda 2. Again, this is type task. Copy the resource. And that's true, right? And let's remove this one, extra comma, we don't need that. So very simple step functions. Now we are basically firing up some Lambda functions. So, and now as I said, I'll go over some more example and show you all complicated stuff with this as well. But understanding the basics is very, very important, I believe. So let's go to this one. I would just click on edit. So, oops, I think I copied the wrong one. Oh yeah, I gotta start from Lambda 1. So let's remove that one, and yeah, so we have a Lambda 1, Lambda 2. We are firing up some Lambda functions, okay? What I would do is click on save. Let's go to the state machine. Let's start the state machine. Name, passing some JSON, just start execution. As you can see, the first Lambda did fire up. Step input was her name. This, oops, sorry. The input was this. The output was hello from Lambda 1. Then the second Lambda got an input hello from Lambda 1. The output was wait, not sure why. Oh, that's because we should have seen Lambda. So I copied the same thing here and here. That's the reason. So I had to copy this one right here. So I made a mistake. That's fine. We'll fix it. So this should now work. So click on step functions, edit state machine. Just gonna edit that quickly. Save anyways. Once that is saved, head over to the state machine, start execution, whatever you want to give input. So now let's see. The input was this, the output was Lambda 1. The second Lambda got an input. Second Lambda got input from Lambda 1, the output was from Lambda 2. So as you can see, everything did work fine. Now guys, I would like to ask you a question. What if this Lambda fails? What would you think happen? You wanna do something, right? If that Lambda fails, you wanna retry or do some sort of stuff, right? So AWS Step Functions allows you to do all sort of stuff like that. So let's create a Lambda called error Lambda. And we'll add this to this one. So I'll teach you now how to add the catch and the retry policies, okay? So click on the Lambda right here. Create functions. Select any runtime, create functions. Now this is how you take care of all exceptions handling and stuff like that. So let me show you, man. I'll tell you what I mean by that. So we have the step function called error lambda, right? So this is basically gonna whenever something goes wrong, it's gonna fire up this lambda right here. Okay, deploy that one. Copy the ARN. Let's head over to this section. So we had this one, right? Now you would like to add some error policies, right? So a step functions, you could do that using a catch block, which is an array of documents. Now here, what I'm gonna do, I'm gonna show you something. If error equals to state.all, that means if anything goes error, I would go to the state called catch fallback, which I would or just call, let's call this error lambda file. Same thing, I would copy here as well if something fails, and I would define this error file lambda. Okay, I haven't defined it, but I would define it here. So collapse this guy right here, collapse this. I think what we did is we are missing a bracket, or maybe no. So this one is this. Oh yeah, I know what I'm missing. It's this bracket right here. Okay, so that's there. That's the state. Now let's define this error lambda here. And what do you think we should do here? So type as task, because you want to fire up a lambda. You would specify the resource, and what do you think is the resource? Is the lambda function, right? So copy the ARN. Okay, so that's that, and this should be pretty much it. So now and oh, one more thing, and this is the last step, right? So we have to tell that using we have to tell that to lambda that, hey, after this there's nothing there, so end true. Let's try to use the state this one and see if it works. So edit state machine. As you can see, lambda 1, lambda 2. If something goes wrong, lambda 1 goes to this, lambda 2 goes wrong, something goes wrong, goes to this. Say save button. Save it. Now let's run this and see if it works. So I'm just gonna run the state machine. It should run fine. As you can see, both worked fine. Now I'll purposely do something crazy on the lambda 2. Or let's do that on lambda 1. So I'm gonna throw or raise an exception, or do some sort of that. Okay. So I'm just raising some exceptions, so the code has to break now. That's the idea. So what do you think? Now this should be red, and automatically it should go to this state right here. This won't execute lambda 2. So let's see if it works actually, man. New execution, start, and I'm expecting it to break. And as you can see, guys, this one did break, caught error, right? It clearly shows you that. And this lambda was fired. So the input was the error message. So error message, error type exception. So you have the complete error message. Oh, sorry, let me just show you that. And that's the output, error lambda fired. So how easy it was to do things like this. Now let me show you a branch lambda. How do you do branching, right? So let me show you about that. So in order to do a branching here, so let's say this returns some data, right? The lambda 1 returns some data. So what we want to do is basically let's take a small example that I would like to show you. And this is usually what I follow. So I'll show you what I'm trying to do. Not there, but I'm just gonna copy some JSON data, and I want to show you something really nice. Okay, so I'm showing you branching now. So that's the data. Okay, so let's go to this guy right here. Now remove this erase block. Oops. Actually I can, I can just copy this lambda. Okay, so basically guys, this one returns a okay, a little bit I'm just trying to format it so I can show you a little bit properly. So a JSON formatter would be great to show you. So we understand a little bit what I'm trying to say. So we have this data which has an nested array. So say if the value inside this array is greater than 0, you want to fire up some other lambda. If it is not, then fire up some lambda. What I'm trying to say, if the array length is, if there is something in this array, you want to fire up something. If it's something is not there in the array, you want to fire up something else. So this is a classic example of branch logic here. So I'll show you what we gotta do. We gotta do some tweaks in the code. So I'll show you. This is my lambda, right? So we have this. So before returning the data, you gotta return the length, item length. So item. So what I'm trying to do, yeah, I'll just do it here. Data count. So first you have to change your code to support things like this. Is my logic. This is how I usually use it. So, but yeah, you can use your whatever you wanna do. So now I would have a variable called item count, and I'll show you how things looks like. And what I would like to do as well is I just wanna, because I wanna show you. Now we are learning about branching, okay? So test, whatever, it doesn't matter. So click on the test, and I wanna actually test it out. So yeah, you would have you have three items, right? Now based on this variable, I would like to do certain branching. Well, how do I do that? So head over to the state machine that we were working on, right? We were doing this. So now this one right here would return some sort of data, and if the data is less than 0, if you have some data in the array, you would like to branch off. If there is no data, you would branch off to something else. So if there is data, and that logic is basically defined using a, so first of all we define a state called if what I want to do here is for now, okay, and then here I would define a choice here. Let me show you, give me 1 sec. I think I just, so this one we need basically a choice here. I'm gonna paste some of our snippets. So after this first lambda, I would now like to fire up this lambda to see if the data is there. If data is there, I would like to fire lambda 2. If data is not there, I would like to directly go to the error lambda, right? I want to do some sort of branching now. So this one right here, we says that we define a state. So this first lambda goes to this state. We say, hey, choice. So choice. Now we say here, remember in the code I showed you, right? The code of this lambda returns a item count, right? So now in this logic, what I will say, if $item count variable is this, if number is greater than 0, then the next state would be lambda 2. So if everything worked fine, go to lambda 2. If number is not greater than 0, that means something went wrong and the data was not there. Fire up error lambda, man. So now with just that being done, I would like to show you how the step function looks like. I think I have to go here. So step functions. So this worked fine. I showed you the error logic. Now we are showing the branch logic. So go here. All right, perfect. So what we are doing here is, hey, start lambda 1. Check if the data was there. If the data was there, fire up lambda 2. If the data was not there, go to error lambda. If lambda 1 failed, go to error lambda. If lambda 2 failed, go to error lambda, else end. So you got the logic, right? So now we are adding more and more complicated stuff. Now this is a branching example. So save that and I'll show you we'll run it. And you expect it to follow the trajectory this way because everything worked fine. Now what I'm gonna do is I'm gonna purposely mess up lambda 1. So this JSON document right here, I'm gonna delete that. So now the item count is what, 0, right? So now when I fire up, it should come here and it should directly branch to this one. Lambda 2 should not be fired up. So new execution, fire up again. I think I did not save it. That's might be the reason. So let's see. So let's see the Lambda 1 first. See, the output is this one right here, item count 3. I think I did not save it. So, oh, I did it in the wrong Lambda, first of all. That's the reason. So I gotta do this in this Lambda. So remove this document right here, save it. I click on the deploy button right here. And now when I do 1, 2, and it should go here, okay? So I'm assuming my logic is correct. There you go, guys. 1, 2. So since in this one, the output of count is 0, this state right here did the comparison and directly branch it to this one right here. You see how easy it was to do some branching? Easy, right? Now let me show you how to do an iteration, or how to, if you have a lot of objects in an array, how you can do some processing in parallel. So now the next part is showing you about that, okay? So I'll teach you about that. Let's take a look at the iterator in step functions. This shows a very nice example of iterator. I have a very simple example. So this one right here, this step function, or this Lambda would return a JSON response of certain objects that I think I did show you. So it's gonna return this array, right? So for each of this, I wanna loop over it and fire up another state. How do I do that? All that stuff, yeah, it's easy. So fetch record, so this one right here basically would pass your JSON, right? So say this is return, this Lambda fetches the data from the database, and now for each record you want to do something. So I just named this as a batch process. You can name it anything you want. I set the type as map. Now the map basically says that this first step is gonna return me a JSON object, and then I say items path. That means this is the data path that I gave. So $things.pirates say. So let me try to pull this up. So pirates say you have these objects inside that. Now I said an iterator because I would like to iterate over that data, right? So I said start at, so basically it would fire up a Lambda, and then I defined my states inside that. So whatever you will want to call. So basically for each of these documents, it's gonna fire up Lambda functions one after the other. Right, so you could do some stuff like that as well. And at the end of that, so at the end of the state, I say that once this is complete, go to this combined result state, which is this one right here. So if you try to visualize things in AWS, this is how it looks like, right? So you have a fetch record. Actually, I'm gonna run it and show you. Copy the JSON, but yeah, it's fine. So no, I gotta go to state machine, my state machine, new, start new, paste in the data, start. So now as you can see, my first step function received this JSON data. The output was of course this one. Now this one was an iterator object, right? So my first object, so I mean click on this one. So the first return var, which is this one, I guess, right? Sorry, it should be, it starts from a 0-base index, right? So this one is an awast, yar, and walk the plank. So you return all of that. And at the end of that, once the state is complete, remember we went to this combined result. And this basically would dump after processing or whatever you want to do something with that those data, you could spit that out, and then you can do some further processing. So if you want to use an iterator in AWS Step Function, that's completely doable, and that's how you would use an iterator. Just a recap. First state, you define some Lambda that would fetch some data. Second, once you fetch the data, you want to basically loop over that data. So you can use something like this. And for each of the iterator, you can fire up a Lambda function or do whatever you want to do. The upload to Dynamo, blah, 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 whatever, XYZ. So you could do that, and once it's complete, you can go to the next state, or you can just say end as true here. So that's done at the end. So yeah, this is how you could do that. And if you want, you could have further processing inside each of these loops. For example, first it fires up this, then it fires up a next one. So yeah, stuff like that is also doable. So for example, I just want to show you whatever. I'm just like copy pasting it, but next. Okay, let's just visualize this workflow. I'm not gonna run because it costs me money. It's my personal account. Wait a minute. All right, let me see what did I screw up. So batch lambda 1. Oh, I think I got a what did I mess up? I'm pretty sure I messed up something. Oh, I see. This name I messed up. That's fine. Yeah, no worries. So batch lambda 1, batch lambda 2. Come on. Oh, next. That one end is true. This one has to start from batch lambda 1. So take a look at this workflow. Why do I have an, oh, I know why. Typo mistakes. All right, so you could do something like this too, like mini, like micro task inside those step functions. It's absolutely doable. So it's all up to you how you want to design your step functions, you know. So this is basically about the map step function. So I think using all of these approach, you should have a pretty good understanding about step function now at this point. You understand step function, how the states, the next variable, the iterator object, how to select data using the dollar symbol. I walked you through certain definitions. Yeah, that's pretty much. Well, thank you so much for watching my AWS Step Function tutorials, and hope you did enjoy and learn something new. If you had any more questions, list your question in the comments. As usual, guys, keep smiling, keep coding, and I would see you guys in the upcoming tutorials and